One reason tiny systems are so satisfying is that they do not need a hidden director. The whole trick is local information. A cell checks its neighbors, a grain checks whether a pile is too steep, a search wave checks the next open square, a raindrop checks which nearby point is lower. None of those rules can see the whole picture. But when the rule repeats thousands of times, the screen starts to look planned. Start with a noisy cave map. Every square asks a simple question: how many nearby squares are walls? If the answer is high, it becomes a wall. If the answer is low, it becomes open space. One update looks random. Two updates start to soften the noise. After a few rounds, the cave has chambers, borders, and tunnels. The rule never said make a cave. It only said copy the local majority. The sand pile is even stricter. A pile counts grains. If one stack reaches 4, it spills 1 grain to each neighbor. That sounds like a cleaning rule, but it creates scars. The center keeps overflowing. The pressure moves outward. Stable areas freeze, unstable areas split, and the final image has rings, arms, and repeated detail. Again, the rule has no design plan. It only asks, am I too full? Pathfinding feels different, but it uses the same idea. A flood search does not know the route in advance. It expands 1 step, then 2, then 3. Every visited square remembers where it came from. When the wave finally touches the goal, the path is already stored behind it. The line appears because every tiny square kept one tiny memory. The river map adds feedback. A digital raindrop falls onto a height map. It moves to a lower neighbor. As it travels, it scratches the ground a little deeper. Later drops are pulled into those scratches, then they deepen them again. This is why a random shower can turn into channels. The rule writes a track, and the next rule reads it. These examples look unrelated: caves, sand piles, roots, rivers. But they share the same engine. There is a local test. There is repeated motion. There is memory left behind in the world. That is enough to turn noise into structure. This is also why small simulations are useful for explaining bigger systems. A traffic jam, a market, a forest edge, or a rumor can all start with local choices. The surprising part is not that the rule is complicated. The surprising part is how far a simple rule can travel. So when a tiny animation suddenly looks intelligent, do not look for a secret controller. Look for the little question being asked over and over. What can I see nearby? What should change next? And what did the last step leave behind?